Good morning, everyone, and welcome. I'm delighted to have you here today. My name is Dr. S.K. Singh, and I will be guiding you through our discussion on the calibration of melting point apparatus. Today's presentation is titled Calibration of Melting Point Apparatus, and it's designed to give you a clear understanding of how to properly calibrate this essential instrument. We'll cover the basic principles, the step-by-step process, and some best practices to ensure accurate results. So without further ado, let's get started. Let's take a closer look at the objective of calibration for the melting point apparatus. The main goal here is to ensure that our instrument provides accurate, traceable, and repeatable temperature measurements. This is crucial for maintaining the quality standards we adhere to in the lab. When we calibrate properly, we're not just checking the instrument, we're making sure that the data it produces is reliable and consistent over time. Calibration is key to meeting various standards, such as those outlined in pharmacopoeial texts like USP 741 and pH, UR 2214, as well as GMP and GLP quality systems. When our melting point apparatus is calibrated, the data we gather for tests like identity and purity are trustworthy. On the flip side, if the instrument isn't calibrated, it can compromise the integrity of our data. This can lead to issues during audits and might even cause us to question the validity of our test results. So, calibration isn't just a routine task. It's a vital step to ensure our measurements are accurate and compliant with industry standards. Now, let's focus on the importance of calibration, specifically for the melting point apparatus. Proper calibration ensures we're consistently getting precise temperature readings, which ultimately supports the quality and reliability of our testing processes. Let's talk about calibration. Calibration is essentially the process of checking an instrument's measurement output against known standards. If needed, we then adjust the instrument so that its results fall within specified tolerances. This ensures accuracy and reliability. In the context of a melting point apparatus, calibration is especially important. It helps confirm that the temperature readings we see are truly reflecting the thermal events of the substances we're testing, based on reference standards. So, in simple terms, calibration is about making sure our measurements are correct and trustworthy. It's a key step in ensuring the precision of our analysis and maintaining the overall quality of our results. Let's talk about reference standards for calibration. When we're calibrating melting point equipment, we rely on common, certified reference materials. These are materials that have well-documented melting points, which means their melting points are precisely known and recorded. Using these reference materials helps ensure that our measurements are accurate and consistent. It's important to choose standards that are certified because this certification guarantees their reliability. By referencing these standards, we can verify that our instruments are performing correctly and maintain quality control in our analyses. Overall, using certified reference materials is a fundamental part of ensuring our melting point determinations are trustworthy and reproducible. Let's talk about calibration frequency and triggers. Typically, calibration should be done before the first time you use a device. This ensures accuracy from the very beginning. You should also calibrate at scheduled intervals. Think of monthly or semi-annual checks to maintain reliable measurements over time. Additionally, calibration is necessary after any maintenance or repair work, since those activities can affect the device's accuracy. If you move the equipment to a new location or notice a significant temperature drift, that's another clear sign that calibration is needed. Guidance generally recommends calibrating at least twice a year for thermometers and temperature scales. This regular calibration is crucial because it helps ensure that your temperature measurements remain accurate and trustworthy, which is essential for maintaining quality and safety standards across your processes. Before we begin calibration, there are a few key steps to ensure everything runs smoothly. First, make sure the apparatus is thoroughly clean and stable at room temperature. This helps prevent any contamination or temperature-related inconsistencies. Next, always use dried reference standards, and in some cases, drying them over silica gel can be beneficial to remove moisture that might affect the results. It's also important to confirm that your capillary tubes are suitable for the measurement and properly labeled, so there's no confusion during the process. Now, when preparing your samples or standards, start by grinding the reference standard into a fine powder. This ensures uniformity and accuracy in your measurements. Then, pack the powdered standard into a sealed capillary tube, filling it to about 3 to 5 millimeters in height. Make sure there are no air gaps and that the packing is well compacted, because any loose or uneven packing can lead to inconsistent readings. These pre-calibration steps are essential because they help maintain the integrity and reliability of your measurements, which ties into the overall goal of achieving precise and reproducible results in our analysis. Now, let's walk through the calibration procedure. First, you want to set your instrument to the correct heating rate, which is usually around 1 degree Celsius per minute, but always check your SOP to confirm. This ensures consistency and accuracy in your measurements. Next, insert the reference standard capillary into the instrument. This standard helps verify that everything is functioning properly. Then, you'll heat the block to approximately 10 degrees Celsius below the expected melt point of your standard. This step is crucial because it allows you to observe the melting process without overshooting. As the sample heats, record the start and end melting temperatures. These are the key data points that tell you how your instrument is performing. Finally, compare these observed values with the certified ranges provided for your standard. This comparison helps verify the accuracy of your instrument and ensures reliable results for your samples. Remember, proper calibration is essential for maintaining the precision and consistency of your measurements throughout your analysis. All right, let's take a look at Slide 8, which focuses on observed versus certified values. First, I want to clarify what we mean by these terms. The observed MP, or melting point, is simply the temperature we measure when we test a sample using our apparatus. On the other hand, the certified MP is the documented melting range provided by a reference standard, which serves as our benchmark. Now, to evaluate how accurate our measurement is, we calculate the deviation, which is just the difference between the observed MP and the certified MP. Essentially, we're asking, how close are our measurements to the known standard? When it comes to acceptance criteria, a common guideline is that a deviation within plus or minus 0.5 degrees Celsius is considered acceptable. This means if our measured melting point falls within this range, we're confident that our calibration is accurate enough for our purposes. Connecting this to the overall theme, maintaining these standards ensures that our measurements are reliable and consistent, which is crucial for quality control and compliance. So, always remember to compare your observed values against the certified reference and check that your deviations stay within acceptable limits. Let's take a look at this calibration record example. Here, you can see how we document the calibration process for a specific instrument. The key points include recording the date of calibration, the person responsible, and the equipment used. Notably, we also document the calibration results, including any adjustments made and the acceptable tolerances. This record helps ensure traceability and accountability, which are essential for maintaining measurement accuracy over time. Connecting this to our overall theme, thorough calibration records like this form the backbone of a reliable quality management system. They provide the proof that our instruments are functioning correctly and within specified limits, ultimately supporting the integrity of our measurements and processes. Let's walk through this calculation example. We start with the observed melting point for acetanilide, which is 115 degrees Celsius. We compare this to the certified midpoint melting point, also 115 degrees Celsius. The deviation here is simply the difference between these two numbers, so 115 minus 115, which equals 0. Since 0 is well within the acceptable range of less than plus or minus 0.5 degrees Celsius, we can consider this measurement accurate. But remember, it's important to repeat this process with other standards across the entire temperature range you will be working with. This helps confirm the accuracy of your calibration throughout the spectrum, not just at one point. Now, when we talk about calibration across a temperature range, the key is to use multiple standards, covering low, mid, and high temperatures. This approach ensures that your instrument performs linearly across the entire range rather than just at a single point. Why is this important? Well, it helps us detect systematic biases, like offsets that might occur at high versus low temperatures. By calibrating across the full range, we're making sure our measurements are reliable no matter what part of the spectrum we're working in. So let's talk about what to do if you find that an observed value falls outside its certified range. First, it's important to double-check your sample preparation and heating rate. Sometimes, small adjustments here can make a big difference. If the issue persists, try repeating the measurement using fresh capillaries to rule out any contamination or damage. If you still see the out-of-tolerance result after these steps, then it's time to adjust your instrument, following the manufacturer's manual carefully, or consider engaging a service engineer for assistance. And remember, always document any out-of-tolerance events you encounter. Keeping a record helps with troubleshooting and ensures that corrective actions are tracked properly. This process is crucial for maintaining accuracy and reliability in your testing. Let's talk about documentation, which is a crucial part of maintaining a robust calibration program. It's important to keep detailed records of all calibration activities. This includes reference standard certificates of analysis, or COAs, which verify the quality and traceability of the standards used. You should also document observed temperatures and any deviations that occur during calibration. These details are vital because they provide transparency and help identify potential issues early on. Acceptance status and signatures are equally important. They confirm that the calibration has been reviewed and approved by authorized personnel. Remember to note the calibration date and the next due date to ensure ongoing compliance and timely calibrations. Good documentation isn't just about record keeping. It supports audits and accreditation efforts, whether you're working under GMP, GLP, or ISO 17025 standards. Clear, thorough records make it easier to demonstrate compliance and maintain the integrity of your calibration processes. Let's now discuss some best practices to ensure reliable melting point measurements. First, calibration is absolutely essential. It guarantees the accuracy and traceability of your results, which is critical for quality control and regulatory compliance. Using certified standards across the entire temperature range, you work with helps maintain consistency and confidence in your measurements. It's also important to evaluate any deviations by comparing them against established acceptance criteria, such as plus or minus 5 degrees C. This way, you can quickly identify if your equipment is performing within acceptable limits. And finally, don't forget to document all calibration activities thoroughly. Proper records are vital not only for internal quality assurance, but also to meet regulatory requirements. By following these best practices, we ensure our melting point measurements are precise, reliable, and compliant, supporting the overall integrity of our analytical processes. If you need any further support or have questions, please don't hesitate to reach out. We're here to help you succeed. Thank you so much for your time and attention today.